Okay, let's start. In the geometric way of thinking, what we are going to do is we are going to take this equation and we are going to plot. What are we going to plot in this equation? We are going to plot x versus x dot, okay, putting x in the x-axis and x dot in the y-axis, okay. And what do we get if we plot like that? Okay, yes, so this is what we get, okay. So x dot is equal to sine of x, which is this curve. Okay, so now the initial guess is x is equal to pi by 4, right? When x is equal to pi by 4, we have been asked what will happen as t goes to infinity to the x, right? So at this point, which is x, okay, at that time what is x dot? The x dot is around 0.707, right? Okay, so what will happen to x at that point in that case if the x dot is 0.707? So one thing we could understand, the x dot is positive, right? At x is equal to pi by 4, x dot is positive. If x dot is positive, whether x is going to increase or decrease? So x dot is positive, so x is going to increase. So if x is going to increase, then from this point, is it going to go in this direction or in this direction? So x is increasing, so it's going to go in this direction, isn't it? So if it goes in this direction, and at this point what will happen? It's still x is positive, sorry, x dot is positive, so it will go in this direction again, in this direction again, the same argument until it reaches this point. Once it reaches this point, what is x dot? X dot is 0. What does that mean? There is no change in x, okay. So if my initial condition is in this region, then I will reach over here, which is pi, okay. That's what we have obtained in our earlier video as well, or in the earlier approach, right? Okay, what if the initial condition is above pi, okay, let's say 4. So at that point, what is my x dot? X dot is actually a negative value. If x dot is negative value, x is going to decrease. So which means x is going to go in this direction until it reaches again the same pi value, okay. So if my initial condition is anywhere in this region, which means from pi to 2 pi, my final value of x is going to be just pi, okay. Okay, now what if x is about 2 pi, okay, the initial condition x naught is about 2 pi. At that point, x is positive, sorry, x dot is positive, so x is going to increase, so it's going to go in this direction and it's going to approach a different final value, which is 3 pi, right? And also if we see, if we go to the negative value, let's say negative pi by 4, what is negative pi by 4? Okay, this point, at this point x dot is negative, x dot is negative, x is going to decrease, so it's going to go in this direction and it's going to approach this point, which is minus pi. So we have obtained a similar result in the previous approach as well, right? But for that we have to solve that complex equation, and then we have to put the initial condition, right, and then we have to see, we have to plot it and see what is the final value. Okay, but here I haven't done any of those things. All I have done is I have just plot x dot is equal to sine of x, and then just from that plot I was able to identify what is the fate of x, what's going to happen as time increases, right? And this is known as graphical way of thinking. Okay, so one more thing I want to show, which is this one. So that's the plot we have discussed, and now if you see in the x-axis here we have put the arrow mark in this direction to represent if my x is over here, it will go in this direction, and if my x is over here in this region, it will go in this direction. Okay, and these points where this curve and this x intersects, which means at the points where the x dot goes to 0, at that point there won't be any change in x, right? Therefore they are known as fixed points. Okay, so this point, this point, this point are fixed point, the points where the x dot is 0, which means there won't be any change in x if the x exists over there. Okay, but among those fixed points, if you see, some of the fixed points are represented in a full solid dot. Okay, the others are represented like a hole. Okay, so what is the difference? The difference is, if you see these values, the arrow marks are approaching to the fixed point, then it's been represented in this manner, and if it's going away from the fixed point, then that's been represented in this manner. Okay, so what does that mean? It means this fixed point is a stable fixed point, where this fixed point is an unstable fixed point. If you give a little disturbance, it will come back to its fixed point either in this direction or in this direction. Okay, but that's not the case for this fixed point. If you give a little disturbance over here, it will keep on going and go to the next fixed point, next stable fixed point. At the same time, if you give a little disturbance in this direction, it will go in this direction and finally reach this fixed point. Okay, therefore this is known as stable fixed point, and this is known as unstable fixed point. Okay, so therefore we have a different representation for these fixed points. Fine. So so as a summary, what you have done in this graphical way of thinking, all you have done is plot x dot as a function of x. Okay, and then you have drawn, depends on whether x dot is positive or negative, you have drawn these arrow marks, and that's it. Okay, one more thing you have to do is draw the fixed points, and also you need to draw whether those fixed points are stable fixed point or a stable fixed point or unstable fixed point. Okay, so that's what you have to do in solving these problems in graphical approach. Okay, so now what you have to do is, okay, the book which I am referring is Nonlinear Dynamics and Chaos by Stephen Strogatz. Okay, so in this book what you have to do is you have to solve some example problems, and you have to solve this example 2.2.1, where you have to identify the fixed points and classify their stability for this system, okay, x dot equal to x square minus 1, and then in the second problem you have to do it for this system. So for this system you have to derive the differential equation, and then you will obtain the differential equation in this manner. And for this differential equation you need to identify where is the fixed point and what sort of fixed point that is, okay. And you need to do the same for the third example, which is x dot is equal to x minus cos x, okay. So those are the example problems I want you to do, and then after you finish those examples, then we will continue the lectures for the next section on population growth, okay. Thank you.